Alright, welcome. Today we're going to go through this paper. We're going to be focusing on the questions that some of my students have found the most tricky, most challenging, so we're going to jump around. We'll start with question 6. It's saying that we need to estimate the total amount of money raised by the students in this class. We can see that there is a range of data that we're dealing with. So 4 students raised between 0 and 6. So our first job to estimate the total number is to first find my midpoints. So first we're going to do midpoint. Excuse my writing, it's the first time I'm using a pencil. It's quite different. So the midpoints that we're going to be looking at are all of these values over here. So to find the midpoint, there's 2 ways that you can go about it. You can either take the upper and the lower numbers, add them together and divide by 2, or just have a look via observation. So our first point there is going to be 3. Then between 6 and 12 we've got 9. Between 12 and 18 we've got 15. Between 18 and 24 we've got 21. And then between 24 and 30 we've got 27. Okay, so those are our midpoints. Next we need to find fx, which is basically a combination where we're going to take the frequency and we're going to multiply that by our midpoint. So we get 4 times 3, 12, then 6 times 9, we get 54, and then timesing 8 by 15 is 130, and then 9 times 21 is 189, and then finally 3 times 27 is 81. After that we're just going to find their total, add them all together, and then this will give us our estimate. So our total for the estimate for the amount raised would be £466. Next up, we have got to describe fully the single transformation that maps triangle A onto triangle B. When you get these described fully questions, your goal is to determine what type of transformation has happened. So if I take a quick sketch of my triangle, that's a little bit rough, but it'll do, and we place the object and the image on top of each other, so triangle A and triangle B, we can see that the image hasn't been rotated or reflected in any way. They're basically on top of each other. Just B is a lot bigger than the original. So already now know that it has been an enlargement. Then we now need to think, okay, you need a couple of points in order to show that it's an enlargement. You have to know where it came from and by how much. So first off, we're going to take our ruler and just draw a straight line through all of my related vertices. Oops. There's the next. And there is your final. And you can see that quite handily, all of those then cross over at a single point, which is your center of enlargement. So we know that the center of enlargement is at point 1, 0. So that's my center of enlargement. Next thing that we need to know when dealing with enlargement is my scale factor. So by how much did it get enlarged? To do that, we're going to do one of 2 things. We can have a look at one of my sides, say for instance this side here, and the related side in my image, and then see, okay, well, in the object, so the original shape, it was 1 block, whereas in triangle B, it is now 2. So we can see that it's been doubled. So my scale factor is 2. The other way to do it, just in case it's not a nice, easy, straightforward one, would be to have a look from my center of enlargement. It's gone up by 3 and across by 1. To get to my original, and then the new one went up by 6 and across by 2. So there, once again, you can see that my scale factor is still 2. Okay, so to answer that question off, you basically just say triangle B has been enlarged by a scale factor of 2 from point 1 0. Or from center, 1, 0. Okay, so here's a question that looks like it's going to be with similar triangles. We can tell that with the parallel lines, and we have two sides that are linked together. Thankfully, all of this information is already on the diagram, so I don't need to worry about that too much. But to find my first step, I need to find my scale factor. So how much they are being multiplied, or what the small side is being multiplied to get my big side. So we go take two sides that are linked together. So these two sides I'm going to use to find my scale factor. To do it, we're going to say, okay, well, 13.5 divided by 6, and that will give us 2.25, which is my scale factor. Now that I've got that, I can use it to find any missing side so long as I have got the related side of the other triangle that is similar to it. So we need to calculate the length AB, which is this length over here. So we can see that that is related to my 11.7. Right, so let's find it. We're going to take 11.7 and we're going to divide it by my scale factor, which is 2.25, which gives us 5.2 centimeters. Wonderful. Calculate the length of ED. So here again, we've got one side. The side that we're going to be working with is AE, and we need to find ED. AE is the smaller of the two triangles, so to find the other side we're just going to multiply. So let's do that. Our small side is 4 centimeters, so we're going to take 4 centimeters and we're going to times that by my scale factor of 2.25, which will result in 9. But there is an extra step. You need to realize that what we've just calculated is the side length of the bigger triangle. So we have just calculated that length there, but they are asking us to find ED. So my final step is just to take my value that I just calculated and minus 4 away from it. So if I just take away 4, I get 5. So ED is 5 centimeters long. Right, so here we have to simplify a algebraic fraction. On the top we've got a difference of 2 squares. You can see that because we've got difference being the subtraction, and then we've got 2 squares, so 2 square numbers. And when we see this, we know that our brackets are always, one is going to be a positive, one's going to be a negative. We're going to have the x's in the front, and then the square root of my other number. So in this case, 5 times 5 is 25. So we've got a difference of 2 squares resulting in those two brackets. At the bottom, we've got a quadratic. So the top of our fraction actually gives us a little bit of clue. When we're simplifying, or when we're expected to simplify, we know that one of these brackets is going to probably need to cancel with the one on the bottom. So we should look out for that when we are factorizing this. Because there's this 2 in the front here, we are going to have to take it a little bit further. So we're going to use the table tennis method. We have the factors of 2 on the left and then the factors of 5 on the right. So I'm just going to try 2 and 1 and 5 and 1, and then we'll see. So the table tennis method, we times top and bottom, 2, 5 and 2, and then we need to ask ourselves, is there any way that I can add or subtract this that will result in my center number? And well, there isn't. So I am not going to be able to use this combination. So all I do is I take the same numbers, and instead of writing that 5 up at the top, I'm just going to switch it round. So doing the same thing, 2 times 5, 10, 1 times 1, 1. And now I look, I can take those 2 away to give me 9, but more specifically, it has to be a minus. So I need that 10 to be a negative so that it results in a negative 9. So I know that this is going to be a minus 5. So this now forms my two brackets. So I just write them out: 2x plus 1 and x minus 5. Now that I've done that, we can see, okay, there we go. There's the two brackets that I can cancel. So I'm left with x plus 5 over 2x plus 1. And that's my answer. So here we're going to add algebraic fractions, and nothing changes. Just because you got x's, y's, etc. in this fraction, the basic fundamental rules still stay the same. So in order to add this fraction together, we need to get a common denominator. So we're going to start with the two numbers as they are, and I can see that my denominator on the left is 5, denominator on the right is 3, so I'm just going to multiply them by each other. So we'll get 3x plus 3 on the top. On the bottom we get 15 plus 5x minus 2 on top, and then my 15 on the bottom. I can expand those brackets and bring it over a single denominator. So my single denominator is 15. Expanding this, we're going to take 3x plus 9 plus 5x minus 10. Okay. And then I just need to collect my like terms. So I'm going to have 8x minus 1 over 15. Perfect. Next up, we have to simplify this expression. Okay, first off, when your indice is a fraction, like a third or a half, I hope you know that a third is equivalent to a cube root and a half is equivalent to a square root. So when we apply this to my 8, we're basically just cube rooting my 8. So I'm left with 2, and then I'm just going to multiply this into the rest. So it would be a9 over 3, e6 over 3, which we can simplify quite nicely to be 3e squared. And that is my final answer there. Right, so now we're going to go on to functions. First off, we need to find f of g of minus 4. This is basically saying, start here, we're going to plug in minus 4, and then that answer we're going to then plug in to my f of x function. So let's start with that. We're going to start with g of minus 4. So I'm just going to take that exact equation, x squared minus 10, and all I'm going to do is wherever that x is, I'm going to replace it with minus 4. So therefore 4 times 4 is 16, and remember, when we are squaring a negative number, that's going to disappear. So that's going to become 16 minus 10. So my answer there will just be a positive 6. Now we need to do this step over there, where we're going to plug that into the original. So we're now going to say, instead of f of x, we're going to say f of 6, because we're going to plug that number in there. And then we're going to rewrite it 2x minus 5. But obviously, instead of that 2x, we're just going to write 2 and substitute the answer from the previous one. So 6 times 2, 12, minus 5. So my final answer there is 7. Then finally express the inverse function f of minus 1 in the form f minus 1x. Okay, so here I've actually got a video on this which I'll link up in the top, but essentially all that we're going to do is we're going to take this function as it is, and we are going to switch my x and my y values. So I'm going to rewrite it, except now I'm going to have my equation look like this. That's the first step. So now all we need to do is get y to be the subject of the formula. To make life easy, I'm just going to keep y on the right. Going to move that 5 across, and I get 2y and then I'm going to divide both sides by 2. So my formula then becomes x plus 5 over 2, and that's it. Alright, so now we have to deal with multiplying out surds, and very importantly, we need to get it so that it looks in this form. Alright, first off, we're just going to take the two brackets and multiply them out. So 7 times 5, 35. 7 times -2, -14 root 2. Then 2 root 50 times 5, so that's just plus 10 root 50. And then -2 root 2 times 2 root 50, which gives us minus 4 root 100. Because square root 2 times square root 50 gives us square root 100. You can also think of it like this. 50 times 2, essentially it's the same thing. Alright, so now that we've got all of those brackets expanded, we can look to simplify it. There's nothing much that we can do with 35, so I'm just going to leave 35 as it is. Minus 14, once again, minus 14 root 2, nothing I can do there. Plus 10, that root 50, the root 50, if I take 50 and I use the tree method to prime factorize it, or to break it down into its factors, we can say 2 times 25. So it would essentially look like this, 2 times 25. So we know square root 2 is going to be the same, but square root 25 is then just 5. So 5 times 10 gives us 50 root 2. And then 4 times the square root of 100, which is 10. So 4 times 10 giving us 40. All right. Now we can go further. 35. These are then just going to, we can just add these two together. So square root 2 and square root 2, you can essentially think of them as your variables. So the same rule, if this was minus 14x plus 50x, your result would just be plus 36 square root 2. And we still have that minus 40 to deal with, so I'll just do that on the next line. So we get minus 5 plus 36 square root 2. Almost done, but they want us to have it in this form. So I need a plus b square root 18. So I've got, there's my a term, there's my b term, but this needs to be square root 18. So let's see how we can do that. So to get root 2 to be root 18, you can just think of it as, okay, I need to times 2 by what to get 18? I can see that I'm going to times it by root 9. And in order to make it so that I don't change my formula, I'm going to times it by root 9 over 9, which is the same as 1. Carrying on, we've got that minus 5 hasn't changed, plus 36 root 18, because root 2 times root 9, over root 9, and root 9 is essentially just 3, so 36 divided by 3 is 12 root 18, and that's my answer. Next up, the cylinder has a radius of 10 and a height of 10. The center, the base of the cone coincides with the center of the cone. The total surface area of the solid is a centimeters squared, and we need to show that it equals that, or they're basically asking us to put it in that form. So we're working with the surface area, so we're going to work that out first. The nice thing is, most of these formulas are actually given to you. So we've got, let's call this A, B, and C, which is at the bottom. Okay, so we need to work out those three different surface areas. So surface area of A is pi r L, and that's given to you on your formula sheet. And surface area of B is 2 pi r H, and that's actually just working off the fact that when the net of a cone is unrolled, it looks like that. So the area, this section here, is a combination of this height multiplied by this length here, which is the circumference of my cone. So it's essentially just circumference of my cone times by height. So that's how we get that formula. That's not given to you, so you do have to learn that one. And then the surface area of C, which is just the area of a circle. All right, then we can just go about calculating all of these and plugging in our values. So let's work out surface of A first, and the surface area of A is actually the most complicated because this L is my slanted length. So it is not my vertical height, it is my slanted length. So in order to find that, I'm actually going to have to calculate the slanted length using Pythagoras. We know that the radius at the bottom is 10, so that's 10. We know that the height is 10, so using Pythagoras, we need to say a squared plus b squared equals c squared. So we've got 10 squared plus 10 squared equals c squared. So we have got 200 is equal to c squared. And we need to get it by itself, so we square root both sides. So my slanted length is equal to square root, or my L is equal to square root 200. And then I can just plug that into my formula. So surface area of A is equal to pi, my R is 10, and then square root 200. We can simplify this by breaking this into my square root 200 can be broken into square root 2 times square root 100, which is then just 10 root 2. So we get pi 100 root 2. That's my answer there. Then we go work out the surface area of B. Surface area of B, and the surface area of B is 2 pi r h, 2 pi r h, and that's just plugging in my values, and we get 200 pi for that value. And then surface area of C is pi r squared, and once again that is just plugging in my radius, which is 10, so 10 times 10, so that's 100 pi. And it says to us that the total surface area is a centimeter squared, and we need to show it in that form. So all we're going to do is we're going to add all of these together. So it is pi 100 square root 2 plus 200 pi plus 100 pi. So I'll deal with the ones that don't have anything on them first, and I'm actually going to make it look a little bit nicer and put them in the front. So that's 300 pi plus square root 2 100 pi. And now that we have this in this form, we can see, okay, so there's my 300, so I'm on the right track. And then I have a square root 2, 100, and my pi needs to be on the outside. So I actually have a common factor of pi. So I'm going to factorize this. I'm going to pull the pi section out. So I'll be left with 300 plus 100 square root 2, and my pi is on the outside. And there we go. That's it. Done. Alright, and now we've got a lovely vector question. As before, I've actually just released a video on vectors, so if you need a little bit more help, that's linked up at the top. Unlike the question earlier in this video, they haven't labeled this very well. So that's your job, that's to test to make sure that you're paying attention. So P is the point OM, such that OP is 1/4 OM. Okay, so that's parts and ratio. Q is the midpoint ON. Okay. R is the midpoint PN. And then they tell you a couple of vectors. They say OP, so going from O to P is P, and they told us a little bit earlier over there that it's a fraction, so it's 1/4. So this P is 1/4 of the whole length. So that means there must be 4 parts, so there's 3 parts remaining. 1 part in the first, three parts that's left over. And then they say from O to Q is Q, and this is a midpoint, so I can just double that. I can label it as Q as well. And then they ask us find in terms of P and Q M to N. So to get M to N, I can't go in this direction because I haven't got those vectors, but if I went down to there, I would have just, I'm going against the direction, so negative 4p, and then going with the direction through to m, so plus 2q, and that's your answer. Now we need to find P to R. So P to R. Okay, so I don't have P to R, clearly, but if I found this entire length there, I know that PR is then just half of it, because it's the midpoint. So we can go from P to O, again, that is going again, so that's just minus P, and then all the way through to N plus 2Q, and that is my total length, but don't forget we must still halve that. So we get minus a half P plus Q. Right, so last up, use vector method to prove that QR is parallel to OP. If this is the case, the two vectors will be a scalar difference between the two, but they would both be the same vector. So it would be P times something, P times a half, P times 3, P times 4. As long as we can do that, we know that they are parallel. So we need to find and prove that these two vectors are equal. We've already got OP, it's just P, so we need to try and find QR. To do that, I am going to go along from Q to O, so that's just negative Q. Q to R would be negative Q, and then we're going to go up to P, that's with it, so just plus P, and then down PR we've actually just worked out over here, so I'm just going to stick that straight in, minus 1/2 P plus Q. Cleaning this up, negative Q plus Q, those two just cancel, and then P minus a half P is just 1/2 P. So QR equals 1/2 P, and OP we've already said is P. So you can see that my vectors are the same, and it's just being multiplied by a scalar. Therefore, it is indeed parallel.